At last! This is the episode where we finally get to see the Proxxon in action, cutting some aluminum. Nothing exceedingly difficult, just some contours on 2mm aluminum sheet. This is part of a modification which I've done to my paramotor. We are going to talk a bit more about paramotors at some point. For the time being, it's a Polini Thor 100 and it has some notorious problems with its manual start. This plate is just one of the parts needed for this modification. It is mounted on the engine and it holds the poles in place. The other parts are either 3D printed or bought off the shelf. But that's another story for another time. Anyways, back to our milling project. This is the part in CAD and, with all the yapping about the enlarged working area and wide travel, it still doesn't fit, so I'll have to do it in two operations. So here is half of the plate. I will first have to mill this half, then rotate the part 180 degrees and redo the same operations. Here's how I'm doing it with Fusion 360. First, you need to go from your design workspace to manufacture. In here, the first thing to do is to create a setup. The setup will correspond to all the operations that you will make with the part held in the same position on your table. What I like to do here is go directly to the stock tab and define the stock. The stock is the raw material at your disposal. In my case, this is just aluminum sheet. The offset will be 0 on the top and I'm also going to set it to 0 on the sides. Once I've done this, I have to come back to the Setup tab and choose the origin of my operations. Since I have to rotate the part after the first half is cut, I'm going to choose a point which is easy to reference. In my case, this point right here will be easy to visualize. Once the setup is defined, we can create our operations. For the part that I'm trying to make, we will use 2D contours. Here again, we have a dialog box with different tabs. First comes the tool. In my case, I'm using a single flute end mill, 2mm in diameter. From my rather limited experience, I found that single flute end mills seem to work better than 2, 3 or 4 flute designs. They seem to evacuate chips faster and stand a better chance at not getting gummed up. In any case, we are going to have to set up our tool in the first tab. You can either choose from the existing libraries or create your own tool. I'm going to choose a flat end mill. The number of flutes is 1. The diameter is 2mm. Most of the cutting parameters are normally given by your end mill manufacturer, but if you don't have it, there's always the old method of trial and error, mostly error. In any case, here's what I have for mine. It says that for aluminum, you should use cutting fluid. Is air a fluid? Yes, I think it is. My chart doesn't even cover the 2mm end mill which they sold to me, but I'm going to extrapolate and use the maximum 20,000 RPM. To be honest, even without this chart, I was still going to use the maximum RPM of the machine. Feed rate should be between 400 and 900 mm per minute. That's quite a wide range, but I don't think my stepper motors could handle that kind of speeds, so I'm going to go with a more conservative 250 mm per minute. In any case, too slow of a feed rate will end up in a lot of rub and gumming up of your end mills.
The plunge rate should be between 10 and 20% of the horizontal feed rate, so I'm going to go with a minimum of 25 mm per minute. The width of cut doesn't matter here, since we're basically slot milling, and the depth of cut will be defined later on in the operation. So we can click OK now for the tool and we can select it for our operation.
You can see the same parameters appear here in the dialog box once the tool is chosen. So After not having respected a single parameter from the manufacturer's chart, onwards we go. The next thing to do is go to the Geometry tab and choose your contour. I'm going to do a first operation for the holes, then a second one for the basic contour. Normally, you can do them both in a single operation, but I want to give myself a bit of freedom to check the end mill between operations. The next tab is the Heights tab. Since I don't have any obstacles on my piece of aluminum sheet, I'm going to set all of these heights just above the stock top, but if you have fixtures or protruding fixtures in the middle of your piece, you might want to pay a little bit more attention to this part.
Next, we go to the Passes tab. By default, Fusion will use the full depth of cut and do the whole operation in one pass. You need to check the multiple depths to use lighter passes. This is where we go back to the manufacturer's chart and see what other information we can ignore. Width of cut doesn't matter here since this is basically slot milling. The depth of cut, on the other hand, should be 0.2 of the diameter, so around 0.4 millimeters. But I'm going to be a real gentleman and go with 0.1 millimeters. I really don't want to push the machine too much.
The last tab is the linking tab, where you would set the linking between operations, but since I'm doing separate operations, I'm going to directly click on OK, which will signal Fusion to start generating the G-code. You can then save your G-code on your computer. Time to do the final contour of the piece. Same tool. In my case, I don't want to do a full contour, since this is only half of the part. I will have to remove the two transitions from the interior to the exterior. The only way I found to do this is to select two different chains. I'm planning on gluing the metal sheet to a sacrificial piece of particle board, so I'm not using tabs. Otherwise, if you need to retain the part until the very end, you might want to use tabs, which you can remove afterwards. Same heights, same depths of cut as before, and let it compute. And here is the toolpath which has been generated. Right, so this is one last thing I like to do before sending the files to the machine. I don't know why, but for the first rapid, Fusion will send the machine to its starting point without lifting it. You can see here in the first G0 cycle, there's only X and Y, which might drag the tool on the surface of your part if it's not absolutely flat. So what I like to do is invert these two first lines and save the file afterwards. If you know how to do this the elegant way, please enlighten us in the comments. Here is the metal sheet in the machine. I had to draw a line to be able to flip the part and reference a perfect Y-axis. No fancy probe for me, just the old piece of paper trick for setting the origin in Z. I'm sorry for the crappy focus, I didn't notice it while filming. I was aiming for more of an eye candy kind of experience, but I missed. Problem is that I filmed the next video with the same setup, so the next one will be crap as well. Hope to do better for the ones to follow. Anyway, here is the part. It looks okay for me. The cut is really clean, no wobble there. The holes are round, so no sign of backlash. That's it for now. Hope you found something useful in this video. Good luck with your projects and hope to see you soon.